In this question, they're asking us to sketch the level curves or the contour lines of the function z equals ln x squared plus y squared for the levels c equals 0, c equals -1, and c equals the natural log of 9. So the idea in level curves or contour lines is that we have some function, z, so z, you can think of z as maybe a height, and depending on what your x and y coordinate are, so depending on where you're standing on the xy plane, this function, it's like kind of like a mountain or something like a hill, and this is the height of the hill depending on what your x and y coordinate are. And so the idea with this is it's very difficult to kind of draw this and visualize this. So what we're going to do is we're going to slice this hill or this mountain at different levels, namely the level of the level 0, the level -1, and the level ln 9. And the idea being that at each slice we can kind of see what this mountain looks like at each of these heights. So to do that, the first thing I'm going to do is I'm going to take a look at the height c equals 0. So what I do now is I substitute in the c value for z. So I'm insisting that I'm going to stand at a height of 0, and this is what the mountain looks like. So I fix my height at 0, and then I see what the x and y's look like. Now if I take a look at this, I have 0 on the left side and a natural log on the right hand side. What I can do is I can actually take e to the 0 on the left hand side and e to the ln x squared plus y squared, and the result is e to the 0 is equal to x squared plus y squared, or if I rewrite that, e to the 0 of course is 1. 1 equals x squared plus y squared. This is a circle of radius 1. So what this is telling me is if I look at this mountain or this hill and I slice it at a height of 0, what the slice looks like is a circle of radius 1. I can do the same thing for the other heights. So at c equals -1, I fix my height to be -1. And of course, like I did in the previous one, if I put this in the exponent of e, I can rearrange this to look like e to the -1 is equal to x squared plus y squared. So this again is a circle, but the radius is the square root of e to the -1. So if I took the slice at a height of -1, what I get is a circle with the radius of the square root of -1. So this is another circle as well. Finally, if I look at the height natural log of 9, put that in for my z, and ln x squared plus y squared. If I rearrange this, putting in the exponent of e on both sides, what I get is 9 is equal to x squared plus y squared, and this is a circle of radius 3. So what I can see here is that at the different slices, what I'm getting are different circles of different radius. So if I want to actually go ahead and plot them and sketch them, I've done that in another program, so I can just kind of insert them in here, and I'll just shrink it down so we can kind of see. What you see here is depending on what the c value is, you get circles of different size. So when c equals 0, that was the first case, we had a circle of radius 1. So if I sliced this shape, this mountain or this hill, at the height of 0, what the hill looked like was just a circle. If I sliced it at a height of -1, what I get is a circle again, but with radius the square root of -1. And if I slice it at the height of 9, or ln 9, what I get is a circle of radius 3. So these are the contour lines or the level curves of the function z equals ln x squared plus y squared at these three heights.